Learn like a pro.
Hey everyone, and welcome back to the Explainer. Today we are absolutely cutting through the noise to untangle the fundamental mechanics of the universe. We're talking about force and mass. Let's just get right into it.
So I want you to consider something right off the bat. What is the exact difference between how you interact with the universe and what you fundamentally are? We constantly blur the lines between what something does and what it actually is. And in physics, well, that confusion is a massive trap.
Picture the basic blueprint of motion and matter. There are really two main pillars we use to decode this whole topic. You've got the matter itself, the mass, like a solid sphere, and then you have the forces, the literal vectors pushing and pulling on it. By the end of this explainer, you're going to see exactly how these two pillars govern literally all motion and matter. Here's our roadmap for today. We'll start with the blueprint of physics, then look at the grand divide of forces, contact versus invisible interactions, the true anatomy of mass, the universal constant, and finally, interaction versus intrinsic properties.
All right, Section 1, the blueprint of physics. Okay, so a force is strictly an external interaction. It's a push or a pull. The absolutely crucial word here is relationship. A force cannot exist in isolation, no way. It requires an active exchange between two interacting objects. Basically, it takes two to tango. Something acts and something else is acted upon.
Moving right along to Section 2, the grand divide of forces.
Physics cleanly splits these interactions right down the middle. On one side, you have contact forces, which require direct physical touch. And on the other side, non-contact forces. These act upon an object without any physical connection whatsoever.
This introduces a strict proximity requirement. Contact requires a physical boundary interaction. Objects literally touching or tethered by a string. But action at a distance? That interaction occurs entirely through invisible fields spanning across totally empty space. It's kind of like magic, but it's just physics.
Which brings us to Section 3, contact and invisible interactions.
Let's look at the everyday forces you interact with. On the contact side, you've got friction and air resistance fighting motion, normal forces pushing back from surfaces, and tension pulling through a rope. But then over on the invisible side, you've got forces acting across fields, gravitational, magnetic, and electrostatic.
Stop right here, because we have a major trap alert. There is a huge hidden trap with contact forces. Normal force isn't just a passive number, and friction isn't just surfaces being rough. Let's look at the microscopic framework for a second. Imagine an object resting on a table. If you zoomed way in to the atomic level, the surface atoms are actually like tiny dots connected by springs. When the object presses down, those tiny springs compress, and they push back up. That compression is the active origin of the normal force. It is literally a push. And friction? At a microscopic level, surfaces are like jagged interlocking mountain peaks that actively catch and resist movement. These are extremely active physical interactions.
All right, let's pivot to Section 4, the anatomy of mass.
Mass is the signature of matter. I love this quote because it completely shifts our mindset from how objects interact to what an object fundamentally is. You could take an object away from all other interacting bodies in the entire universe, totally removing all contact and invisible forces, and it will still possess this signature.
At its core, mass is a measure of the amount of matter in an object. Think of it as your absolute particle count. Actually, scratch that. Think of it as the sheer intrinsic amount of stuff making you, well, you. It's a scalar quantity measured in kilograms, meaning it has magnitude, but absolutely no direction.
Down here on Earth, we use tools like beam or electronic balances to figure out this intrinsic matter. But here's a totally wild fact. Up on the International Space Station, where regular balances won't work at all, astronauts measure their mass by strapping into a spring-mounted chair to calculate their inertia. The method changes, sure, but the intrinsic mass remains totally independent of the environment.
Section 5, the universal constant. Let's set up a really powerful thought experiment here. On one side, we have our Earth environment, where local gravity is pulling down on us. On the other side, a deep space environment, a void with zero local gravity. This is where we confront the absolute biggest trap in physics, the relational versus intrinsic trap. People constantly confuse weight, which is a gravitational force interacting with you, with mass, which is your intrinsic self.
See, on Earth, gravity pulls down on you. In deep space, there is zero gravitational pull. Yet, your fundamental particle count,
let's say a mass of 1 kilogram, remains exactly 1 kilogram. Whether you are pinned down by gravity or floating freely in the void, your weight changes dynamically, but your mass, it never, ever does.
Final stretch, Section 6, Interaction versus Intrinsic Property.
Bringing the whole shebang together, force is an external, relational interaction that changes based on your environment. Mass is an intrinsic, constant property. And when these forces collide, say you have a 10 Newton push forward on a block, but it's fighting 3 newtons of active friction backward, they interact mathematically. You do the vector subtraction, 10 minus 3, and you get a resultant force of 7 newtons. Forces dictate the math of how objects interact, but mass dictates what the object fundamentally is.
So let's lock in these key takeaways real quick. Force requires a relationship between at least 2 objects. Mass is purely intrinsic to one single object. Because forces are interactions, they change dynamically based on your location and proximity to other things. But your mass, that is a constant, unchanging signature everywhere in the universe. I'll leave you with a bit of a challenge. Take a second and look around the room you are sitting in right now. Your mass, your intrinsic particle count, is exactly what it was an hour ago. But what forces are acting on that mass right now? Are invisible gravitational fields pulling you down? Are microscopic atomic springs in your chair pushing back up against you? Think about the invisible math happening all around you, at this exact moment. Thanks for joining this explainer, and definitely stay curious.